Eighth graders, this is the first video that I'm going to be posting for our online learning. So right before we left school, you guys took a pre-test over the periodic table and how to determine like the protons, neutrons, electrons, and just different aspects of atoms overall. So this is our first lesson over the periodic table, and the first thing we need to talk about is atoms. So going right into it, well, atoms, what are they? Atoms, they are the building blocks of matter. Now, don't think of don't think of matter as the same thing as cells. Yes, cells have matter in them, but cells only make up living things. Let's say, like our table here, well, my table, or my computer, or whatever you are using at home that is non living, that is made up completely of matter, no cells. So matter, non-living things, cells, living things. So our atoms then, they are the building blocks of matter. Well, what makes up our atoms? We have protons. These are positively charged and they are located inside of the nucleus. We have neutrons. They have no charge. They are neutral and they are also inside of the nucleus. And then on the outside of the atom, we have electrons. These are negatively charged and they are around our nucleus. So with our atoms, for now, our atoms are always going to be neutral. And that's because the number of protons and electrons cancel each other out. So when we are studying it right now in 8th grade, however many protons we have, we are going to have the same number of electrons. The only time that's going to differ, and you might talk about this in high school chemistry, is when you get into isotopes, but we're not covering that at all. So you might see a picture of an atom, usually like this. I know I think about that, especially like if you think of the beginning of the show Jimmy Neutron, they have this. So our protons and neutrons are on the inside, electrons are floating around. We are going to be looking at our atoms like this a lot, and that's because we're going to create these things called Bohr models that shows how many valence electrons are in an atom. So we're going to be drawing ours like this here at the bottom. All right, so we know about atoms. Next we have to go into elements. So elements, these are substances that are made up of only one type of atom. So our elements, you've all seen the periodic table, how they differ or why they have these little numbers up here at the top. They differ because of the number of protons that they all have in them. So our example, hydrogen H has one proton and helium He has two protons. So 1, 2. And they're all on the periodic table of elements. They are arranged by the number of protons in each element. And this is the periodic table song. I'm not going to play it on this video, but I will link it for you to watch. I think we've watched it before, but you know it's my favorite song. And here's a mini periodic table for you. So you see, they're all arranged by the number of protons that are in them. So when we are looking at the elements, there's more than just this number here at the top, which I think we might know what that is, but this is what each of those things mean when you are looking at an element on the periodic table. So in the top left-hand corner, and it might not always be on there in the top left-hand corner, but it's always going to be at the top. That is our atomic number. We have the chemical symbol, that's an abbreviation for its name. Just know that it's not always going to be the same as the actual name, such as tin, I believe, is SN, and lead is PB. So it's not always going to be the same letters as it appears in the name. Just know with the chemical symbol, if it does have two letters in it, the first letter is always going to be uppercase, the second letter is always going to be lowercase. We have the element name, beryllium, and the last thing that we have is the atomic mass. So that's how much matter it has inside of it. So our atoms now. Atoms are super small. Their radius, which is like the whole thing of it, is less than 1 nanometer, which is 1/1000th of a meter. So it's probably hard to visualize that. So think about it like this instead. Trillions of atoms would fit in a single period at the end of a sentence. That is crazy. So while our atoms are very small, elements vary in the size of their atoms. So not every element is going to have the same size of an atom. So if you look at this picture here, if you move across the periodic table horizontally, the atom size decreases. And if you move down the periodic table vertically, then the atom size increases. So moving along periods decreases, moving down groups increases. So what we're going to be focusing on this week is how to determine the number of electrons, protons, and neutrons that appear in an element. And we're also going to be completing a worksheet on this, which I will post another video of to give you an example of what to do. So for protons and electrons, when you're looking at an element, you will look at the atomic number. The atomic number shows the number of protons, and since our elements are going to be neutral, that means it has to have the same number of electrons as well. So looking at the atomic number, you will see the number of protons and electrons that are in that element. And now to find our neutrons, you're going to look at the atomic number and you're going to subtract that with the atomic mass. So kind of flip-flop that. Take the atomic mass minus the atomic number. The atomic mass is usually going to be a larger number than the atomic number, and you don't want to end up with a negative number. So the atomic mass minus the atomic number. So here's our atomic number and our atomic mass again. So going into an example first off, we have beryllium here. So to find the number of protons and electrons, we're going to look at the atomic number. And to find the number of neutrons, we're going to take the atomic mass minus the atomic number. So for our protons and our electrons, neutrons, protons is going to be 4 because of this number in the top left-hand corner. The number of electrons is also going to be 4. And then our neutrons is going to be 5 because we have 9 minus 4. And no, when we are doing this, do not include the decimals behind it. We want it to be a whole number. Okay, another example. So this time we have phosphorus. Its atomic number is 15. Its atomic mass is 30.9. So with doing this kind of math, we do need to round up our numbers. So remember the rule typically is if it's 0.5 or above, you're going to round this number up. If it's 0.4 and below, you are going to round down. So since we have 0.9, we are going to round this up to 31. So our protons, electrons, and neutrons, our protons and electrons, remember they're going to be the same. It's in that top left-hand corner that's going to tell us how many of those there are. So we have 15 protons and 15 electrons. Now for our neutrons, the atomic mass minus the atomic number, remember we just rounded this number up to 31. So 31 minus 15 is 16. So now I'm going to have you do a little bit of practice on your own. So if you want to do it mentally, that's okay. If you want to do it on a piece of paper, that is fine as well. So we have hydrogen here. So we have the atomic number as 1. The atomic mass is 1. So for our protons, it is going to be 1. Our electrons, it is going to be 1. And for our neutrons, we have 1 minus 1. So it is going to be 0. And I believe this is the only time that occurs on the periodic table. Alright, another practice, we have americesium, that is 95 and 243. So our protons, looking at the atomic number, is 95. Our electrons, again, looking at the atomic number, is 95. And we have to take 243 minus 95, and that number is 148. And then our last one here, we have gold, which is Au. So our atomic number is 79. With this one, we need to do some rounding again. So looking at this number here, decide if you need to round up or down. So for gold, our number of protons is 79. Our electrons is 79. And you should have rounded up, so it should have been 197. So you take 197 minus 79, and you get 118. So that's all we're going to be doing for this part of it today. Like I said, on Classroom, I am going to be posting an assignment for you to do. Just know you are going to need a periodic table in order to do that assignment, because it's just going to be determining the protons, electrons, neutrons, maybe filling in the atomic number or the atomic mass, or writing down the chemical symbol or the name of the element for different things that I give you, and I will do an example of that on the worksheet in the next video that I do. So if you want to print off a periodic table, that's fine. We are going to be using it quite a bit here, but I'm also going to provide you with an online periodic table that you can use too. I think it's pretty cool, and I'll show you it in the next video. Alright, if you guys have any questions, please email me, or we can talk about it on our Google Hangouts that it's scheduled for this week. Alright, see you guys later.